Hello and welcome to Math with Mrs. Becker. Today in Algebra 2, we are going to complete section 5.6, which focuses on something called the quadratic formula. Now we have learned several methods for solving quadratic equations. Remember, if something is quadratic, that means that your variable has a power of 2. When you are solving, what you are looking for is the location where your parabola touches or crosses the x-axis. So one thing that we have seen is there are times where you have two solutions. That means that your parabola really touches the x-axis 2 times if they're two real solutions. There are times where we maybe just have one solution. Now we have complex solutions, and what that means is we have something like this. So you don't have any real solutions. That means that your parabola does not really touch the x-axis. And when that happens, that's when we have those complex or imaginary solutions. Okay, so the way that we have solved quadratics, tried to figure out where that parabola touches the x-axis, we have graphed. We used Desmos.com. In 5.1, we did an XY table, and we went ahead and drew a parabola on a coordinate plane that way. Again, that was 5.1, making tables. We've done factoring. We've used square roots. So in order to cancel a power of 2, you have to take the square root of each side. And we have done the complete the square process. Here is yet another method. It is called the quadratic formula. Again, it is a method for solving quadratic equations. Okay, here is the formula, and hopefully you have seen this before. What you need to make sure first is that you have your quadratic in what's called standard form. ax squared plus bx plus c equals 0. So 2x's, 1x, no x's. You want it equal to 0. The number in front of x squared is a. The number in front of x is b. The number at the end that does not have a letter is c. Then you go ahead and fill in the quadratic formula. The really cool thing is the quadratic formula is the one method that can be used to solve any quadratic equation. It always works. Sometimes completing the square can be kind of tricky when you have fractions and all those things. Sometimes you might find a quadratic equation where it's impossible to factor. The quadratic is the one method that you can use 100% of the time. Now, before we jump into the entire quadratic, there is an important part. It is called the discriminant. The discriminant is b squared minus 4ac. It is the value that goes underneath the square root. The discriminant tells you how many solutions we are going to have and if they are going to be real solutions or imaginary solutions. Okay, so if your discriminant, when you calculate b squared minus 4ac, if it's greater than 0, so if it's a positive, you have 2 real solutions. Your parabola would really cross the x-axis 2 times. If b squared minus 4ac equals 0, you have 1 real solution. The parabola would really touch the x-axis at 1 location. If b squared minus 4ac is a negative value, you have 2 non-real solutions, meaning your final answer is going to have an I in it. Remember, you cannot have just a single solution with I because they come in those complex conjugates, so they come as a pair. So you will have 2 non-real, which means imaginary solutions. If you were to graph the parabola, it would never really touch the x-axis. All right, let's go ahead and just practice that part. If you want to find the number and type of solutions, step 1, you have to make sure that you have ax squared plus bx plus c equals 0. Okay, this is not in the right format. I want it set equal to 0, so I need to take the 12x and move it to the other side. My squared term comes first, followed by the x term, which would now be a negative 12x because it was positive here, plus 36 equals 0. Now I go ahead and state what is a, what is b, what is c. A is the number in front of the squared term. It's a 1. B is the number in front of x. It's a negative 12. C is the number at the end. It's 36. So I calculate b, which is negative 12 squared, minus 4 times a is a 1 times c is 36. Now you can enter this into the calculator at one time. You just have to be really careful with the parentheses. So negative 12 squared minus 4 times a is 1 times c is 36. The discriminant is 0. If b squared minus 4ac is 0, you have one real solution. This quadratic, if you graphed it, would really touch the x-axis in one location. Let's look at another one. Step 1, you need it set equal to 0. So I need to take this minus 8 and add it over. X squared minus 4x plus 8 equals 0. Once it's set equal to 0, go ahead and figure out what is a, what is b, what is c. A is the number in front of x squared. B is the number in front of x. C is the number at the end. B squared minus 4 times a times c. I'm going to go ahead and calculate that. So negative 4 squared minus 4 times a, which is a 1, times c, which is an 8. I get a discriminant of negative 16. If your discriminant is negative, you have two non-real solutions. So this quadratic, if you actually graphed it, would never really touch the x-axis. When we go ahead and find the solutions using the quadratic formula, we are going to get two answers and they are going to contain an I. Last one like this. I need to first get it set equal to 0, so I have to minus that 12x over. X squared minus 12x plus 30 equals 0. Again, make sure it's in the right order. 2x's, 1x's, no x's. A is the number in front of the squared term. B is the number in front of x. C is the number at the end. If I calculate b squared minus 4 times a times c, that's the number that goes underneath the radical. Negative 12 squared minus 4 times 1 times 30. I get a positive 24. If this value is positive, we have two real solutions. That means that if you graph, this parabola would really touch the x-axis at two locations. You will find questions in the homework that are just like this. They want you to find the discriminant. Okay, so that is just your one number. Then they want you to find the type and number of solutions. If your discriminant is 0, it's one real solution. If your discriminant is negative, it's two non-real or imaginary solutions. If your discriminant is positive, it's two real solutions. Once you know how many solutions and what kind, we go ahead to the full quadratic formula. Again, you want to make sure that it's in the correct order and it's set equal to 0. This is 2x's, 1x's, no x's, set equal to 0. So A is 2, B is negative 16, C is 27. I start off by finding b squared minus 4ac. So what we just did, to me, that's the easiest way to start these problems. Negative 16 squared minus 4 times 2 times 27. This is 40. Because this is a positive number, I know that at the end, I need to have two real solutions. Now I use the quadratic formula to go ahead and find them. X equals negative b. So you take your b value and you change the sign. So it's 16. Plus or minus b squared minus 4ac. We already calculated that. We have 40. That's what goes underneath the square root. All over 2 times a. A is a 2. 2 times 2 is 4. Your next step is you want to see if this is a perfect square root. It is not. So if it's not a perfect square root, what we need to do is see if we can simplify it. 40 can be created from 4 times 10. 4 is 2 times 2 and 10 is 2 times 5. So I can cross off 2 2's. That allows me to write a 2. 2 and 5 cannot be crossed off, so I circle those. Because there's more than one number, I multiply them to create one number inside. 2 times 5 is 10. All over 4. Last step. Any number that is not underneath the radical, you have to simplify it if you can. So what I mean is if you look at 16, 2, and 4, Is there a number I can divide them all by to simplify this? Absolutely. You can divide by 2. 16 divided by 2 is 8, plus or minus 2 divided by 2 would just be a 1 square root of 10. 4 divided by 2 would be 2. That would be your final answer. Yes, it is 2 solutions because one solution is 8 plus the square root of 10 over 2. The other solution is 8 minus the square root of 10 over 2. So even though we write our final answer in this method, you do need to realize that it is representing 2 solutions. One solution has the plus sign in between. The other solution would have the minus. Let's keep on going. Okay, let's look at the next one. 2x's, 1x's, no x's, it's set equal to 0. So you identify what is A, what is B, what is C. A is the number in front of the squared term. B is the number in front of x. C is the number at the end. So if I calculate B squared minus 4 times A times C, if I calculate that, I already know what the number is underneath the radical. I will also know what type of solutions I'm looking for and how many. I got a 37 this time. 37 is a positive number, so I will be finding 2 real solutions. X equals negative B. B is a positive 3, so I use a negative 3. Plus or minus the square root. I already calculated B squared minus 4AC. That's 37. All over 2 times A. A is a 1. This is your final answer because I cannot break down a 37. Again, this is 2 solutions. Negative 3 plus the square root of 37 over 2, that's one solution. Negative 3 minus the square root of 37 over 2, that is your second solution. Let's keep on going. The more we do these, the easier they get. 2x's, 1x's, no x's. It's in the right order. A is always the number in front of your squared term. B is always the number in front of x. C is the number at the end. If I calculate B squared minus 4 times A times C, let's go ahead and see what we get. Negative 8 squared minus 4 times A times C. Again, I got 24. 24 is a positive number, so I have 2 real solutions. Let's find them. X equals negative B. If B is a negative 8, I use the opposite, which is a positive 8. Plus or minus the square root, B squared minus 4AC is 24, all over 2 times A. A is a 1, 2 times 1 is 2. 24 is not perfect. I see if I can break it down. 24 can be created from 4 times 6. 4 can be created from 2 times 2. 6 can be created from 2 times 3. So I can break this down because I can cross off 2 2's. That allows me to write a 2. Square root, this cannot be crossed off, this cannot be crossed off. 2 times 3 is 6. All over 2 times 1, which is 2. 8, 2, and 2. Those are the numbers that are not underneath the radical. So you need to simplify them if you can. So what you ask yourself is, okay, is there a number that I can divide 8, 2, and 2 by? Absolutely, you can divide them by 2. 8 divided by 2 is 4. Plus or minus 2 divided by 2 would be 1, square root of 6. 2 divided by 2 would be 1. You could put a 1 underneath, or you could just have 4 plus or minus the square root of 6. Again, this is 2 solutions. One solution is 4 plus the square root of 6. The other solution is 4 minus the square root of 6. Okay, we're going to keep doing a few more. Oh, yeah, 2 more, guys, just to make sure we've got it. A, the number in front of your squared term is 4. B, the number in front of x is 3. C, the number at the end is 2. So B squared minus 4 times A times C. If I go ahead and calculate that, 3 squared minus 4 times 2. This is negative 23. If you have a negative, that means I have 2 non-real solutions. So I'm going to have imaginary values in my solutions. X equals negative B. So it's a negative 3. Plus or minus the square root of negative 23 all over 2 times A. A is a 4. 2 times 4 is 8. There's a negative underneath the radical. So remember, what we need to do is take out that negative 1. Square root of a negative 1 is imaginary. 23 is a prime number, so I can't break it down. So this is really an imaginary square root of 23. So here's your final answer. Negative 3 plus or minus an imaginary square root of 23 all over 8. Bam, you're done. Again, it's two answers because one answer would have the plus sign, one answer would have the minus sign. Last question. A is 3 because it's the value in front of x squared. B is negative 1, the value in front of x. C is 8, the number at the end. It's b squared minus 4 times a times c. Let's calculate the number underneath the radical. Negative 1 squared minus 4 times 3 times 8. This is negative 95. Holy smokes. It's negative, so there's two non-real solutions. So I have x equals negative b. Negative of a negative 1 is positive 1. Plus or minus the square root, b squared minus 4ac is a negative 95. All over 2 times a. A is a 3. 2 times 3 is 6. If you have a negative underneath the radical, you need to pull out the negative 1. This is imaginary. Now 95 is not perfect. So if I take 95 and I divide out a 5, I have 19. Well, I don't have a pair. So as crazy as this seems, the square root of 95 is simplified. So we have 1 plus or minus an imaginary square root of 95 over 6. That's your final answer. The reason why I could not simplify it any further is because when I went ahead and divided this, I got 5 times 19. Both of those numbers are prime. They're not a pair of numbers, so I could not cross it off, meaning 95 was in simplest form. That is the quadratic formula. So these slides are just kind of showing you what we've all done. We've done graphing. We used Desmos.com. What you had to do is figure out where across the x-axis. Your value is always x. Okay, so because it's on the x-axis, that's what you're looking for. Factoring, you go ahead, factor, then you take each piece separately, set it equal to 0. Square roots, to cancel a power of 2, we take the square root of each side. When you cancel the power of 2, don't forget we have a plus or a minus. Completing the square, that's the magic number where you take b divided by 2 and square it. And again, you need to know how to factor and how to use square roots and the quadratic formula. That's what we just looked at today. It says no matter which method you use to solve a quadratic, you should get the same answer because all of these methods are doing the same thing. You're trying to identify if you graph the parabola, where would it cross the x-axis? Okay, so if you are looking at your book assignment, 1 through 13, okay, you are going to find the discriminant. So that's b squared minus 4ac. From that number, identify the number and the type of solutions you're going to have. Your options are 2 real, 1 real, or 2 non-real. Then use the quadratic formula and solve. Jump ahead, 45 to 53. You solve using any method you choose. So if you really like the quadratic formula, you could technically do it for all of them. If you really, really like that square root process that we did in 5-4 and 5-5, if you really like the completing the square process, you could go ahead and use that. So you can use any method you want. You can use Desmos, you can create tables, you can factor, you can complete the square, whatever method you choose. So again, your assignment is 1 to 13, practicing what we learned today, the discriminant and the quadratic formula. 45 and 53, you can use any method of your choice, just kind of tying everything together. I hope you had a great time today, and I will talk to you soon.